All right, y'all. So today we are going to do a new topic called optimization, except we'll be using information that we've learned over the last unit to kind of solve these optimization problems. So really quick, what is optimization? Optimization is one of the most common applications in calculus. Um, we often hear terms like least time, greatest profit, shortest distance, maximum, minimum, volume, or waste. In order to optimize problems, we first need to find the quantity that we need to be minimizing or maximizing. So, like, really, we're focusing on the fact that these are all maxes or mins. So, like, least would be like min, greatest would be max, right? In order to optimize them, we will focus on the thing that we're trying to maximize or minimize, and then we'll use our knowledge of calculus to do so. Um, as long as you approach these problems in kind of a like what's the word, in a certain order, and you like follow certain steps, you go with the procedure that's kind of drawn out here, you should be fine in solving these problems. They can get a little stressful at times. So we're just gonna like go step by step, and then if you need to refer back to these steps, you can. But I think that you'll find that the steps feel pretty natural. I would only refer back to these if you're feeling like you're getting stuck. Okay, so here we go. Here is our one example. We're going to do one problem today, and then we'll get some practice in. All right. So first step is to underline like important things. So let's go ahead and do that. I'm going to underline normal things in blue and then calculus keywords in yellow. So find two positive numbers. Okay, we want two positive numbers such that the sum of the first and twice the second number is 64, and whose product is a maximum. Product is a maximum. All right, why is that calculusy? Why did I highlight that with yellow? Because of the word maximum. We are going to try to find a max. Okay. Now, first we need to break down things how we normally do. First, what do we want? What do we want for this problem? We want two positive numbers. Two positive numbers. Let's call these numbers, since we don't know what they are, let's call them x and y. So what do we want? We want x and y. Now, we also want the product of xy to be a maximum. We're going to write that in the givens, though. So what is given to us? Let's write some givens down. First thing that's given, the sum of the first number. What's the first number? Let's call the first number x. And twice the second, 2 times the second number would be 2y, is 64. So we could write an equation to match that. The sum means add it. So x plus 2y equals 64. That's given to us. We also know that the product is a maximum. Product means multiply, so we're going to say we also know x times y is a max. Now, the first thing we're going to do is let's call x times y a function. I'm going to call it, let's say call xy, call f of x. Let's just say it's f of x. xy f of x. So we would write f of x equals xy. Does that make sense? All right, f of x equals xy. Now, we're trying to get xy to have a max. So this is where the calculus comes in. F of x, we're writing the note to ourselves now. F of x has a max if, what's true? If f prime of x changes, maxes happen when f prime changes positive to negative. All right, this is where the calculus is going to come into this problem. We're going to have to do a sign test on the derivative. Now, before we find the derivative, we want our function to only have one variable. As you can see here, f of x has two variables. It has x and y. That means we would have to do implicit differentiation. That makes our life hard. The good news is we have been given something that can help us get our function into one variable. This thing right here is going to help us get our function into one variable. So we are going to say x plus 2y equals 64. Let's solve for y so that we can like plug that into the function down here so that we only have x's. I'll show you what I mean. All right, we're going to solve for y. So 2y equals 64 minus x. Y equals 64 minus x divided by 2. Sweet. Now that we have that, y equals this thing, we can plug that in down here, and then we'll only have x's in our f of x. So let's go ahead and do that now. I'm going to do that over here. F of x equals x times y is 64 minus x divided by 2. Now, we know that we're going to need to take the derivative of f of x, so let's go ahead and like make that easier so that we don't have to use a product rule. Let's distribute that x. So f of x equals, I'm just like simplifying f of x. We get 64x minus x squared. That x distributes to the numerator, divided by 2. I can simplify this even more so that I don't have to use like a quotient rule. F of x equals 64 divided by 2 is 32x minus 1/2 x squared. That's the same as x squared over 2. 1/2 x squared. Okay, why did I simplify it that way? Because I wanted to simplify it in a way that makes my derivative easier to find. So now I can find f prime of x. Remember, I need to find f prime of x to see when it changes positive to negative. So f prime of x equals 32 minus x. Cool. How do I find where f prime changes positive to negative? First, I find where f prime equals 0, and then I do a sign test. So let's find where f prime of x equals 0. So 0 equals 32x, or 32 minus x, sorry about that. X would equal 32. Sweet. Let's do an f prime sign chart now. So I'm going to come over here. We're going to do an f prime sign chart. F prime of x sign test or sign chart. And 32 is where we have 0. Let's plug in numbers on the left and the right of 32 into our derivative. So if we plug in 0 into the derivative, into this orange function, we get 32 minus 0. That would give me a positive. If we plug in 33, we get 32 minus 33. That would give me a negative. So what's happening? Sorry, y'all. What's happening? Oh my goodness. Right here at 32, we could say, so f of x has a max at x equals 32 because f prime changes positive to negative at that x value. So y'all, good news. We just found x. We just found the x that we were looking for. We have a max when x equals 32. Remember we were trying to find x and y? We found x. Now how do we find y? Well, we already isolated y over here. So we can just plug in the x that we have, 32, into that y equation. So let's go down here and plug in that. So we know, I'm going to copy from here, y equals 64 minus x divided by 2. Y equals 64 minus x divided by 2. Let's plug in our x now. Equals 64 minus x was 32 divided by 2. Y equals 64 minus 32 is 32 divided by 2 is 16. Y equals 16. All right, so what the heck did we just find? Let's go back and read the question to figure out like what were we even doing? We just found this. We found x and y. We found two positive numbers such that the sum of those two numbers, the sum of x and 2y equals 64, and the product is a maximum. That's what we just found. So what I would do to end this question is I would just like summarize. I would say, so the two numbers are 32 and 16. Those are the two numbers that answer this question. All right, that's it for today, y'all, and we will get some practice in now.